Hello guys and welcome back to another video tutorial series on searching algorithms. And today we're gonna discuss one of the most popular interview question, and that is maximum subarray problem, which is more commonly known as the Kadane algorithm. So over here the problem statement says that given an array of numbers consisting both of positive as well as negative number, you have to find out the subarray having the maximum summation value. So in one of our last video tutorial, we have solved a problem similar to this one, where we have solved the problem of finding the maximum subarray having the summation value as 0. But in this problem, we're gonna try to find out the subarray having the maximum value. So if you have not gone through that video, I would highly recommend you to go through that video on subarray and then come back to this solution. So I will be attaching that video in the I icon over here. So let's start with the solution of finding the subarray having the maximum sum. So a subarray can be defined as a part of this array having the contiguous number. So for example, over here 4 is a subarray, whereas 4 minus 1 is another subarray, then 4 minus 1, 2 is another subarray. So all the numbers which are contiguous to each other are called as subarray. So according to our problem statement, we have to find out a particular subarray having the maximum sum. So over here you can see that the value of this subarray is 1, whereas the value of this subarray is minus 2. But if you try to find out the sum of this subarray, that is 4 minus 1, 2 and 1, this value is 6, which is the maximum subarray value on this corresponding array. So according to our problem statement, we have to find out this corresponding subarray having the maximum summation value. So the most easiest way of solving any subarray problem is using a brute force method. But over here, to find the solution of the maximum subarray problem, we will be giving both the solution. One, that is the brute force solution, and number 2, the optimal solution, which is nothing but our Kadane algorithm. So let's start with solving this problem using the brute force approach. So the brute force approach of solving this problem is pretty simple and easy. So as you have seen in our last video, for finding any subarray within a given array using a brute force approach, we were using 2 inner for loop to calculate all the possible subarray that can be formed from an array. So over here also, to find out the solution in the brute force approach, we will be using 2 for loop, both the for loop starting from the first index of our array. So on each and every iteration of our brute force approach, we will be calculating the possible sum of each and every subarray that are present over here. So over here, for the first time, the value of this subarray is minus 2. Now on second iteration, we will increase the inner loop forward, and thus our inner loop is now pointing to the second element over here, and the summation of newly created subarray is minus 1, which is greater than the previous summation value, that is minus 2, and that is why we will be replacing the value of minus 2 with minus 1, because our goal is to find out the maximum value of the sum. And in this way, we will keep on moving forward, and at the end of the complete iteration of the 2 inner for loop, you will get the desired solution. So let's implement the Java code of finding the solution of this problem. So let's name this problem as finding maximum subarray. And over here, we will be passing the entire array as our parameter. So at the very starting of the program, we have to initialize one of the variable, that is a global max, which will calculate the possible maximum value for any subarray. Now to generate all the possible subarray from this given array, we have to write 2 for loop, both starting from I equal to 0. So over here you can see that we have created 2 for loop, one starting from I equal to 0 and another from j equal to I, that is also starting from 0 for the first case. And now we will be moving this 2 pointer forward to find out all the corresponding subarray over here. And on each iteration, we will compute the corresponding sum of each and every subarray. And to find out this corresponding sum of each and every subarray, we will define another local variable, and that is sum, which will calculate the summation value of each and every subarray that can be created from this given array of numbers. So over here you can see whatever the subarray that is getting created using this do for loop, I am generating the corresponding sum of those subarray over here. And over here we will be keep on checking that whether the value of this sum, that is the local sum, is greater than that of our global sum or not. And if the value of our local sum is greater than that of our global sum, means we have encountered one of the subarray having the maximum value. And thus over here we will be updating our global max. And at the end of this do for loop, we will return the global max value from this function, which is our required solution. So over here if you see, the solution of this problem using the brute force approach is quite trivial and simple. So what we are doing is like using do for loop, we are calculating all the possible subarray that can be formed from a given array, and on each and every iteration we are getting the corresponding sum of those respective subarray. And if the value of that corresponding subarray is greater than our global max, we are updating the global max over here. Otherwise we are just looping this do for loop to generate all the possible subarray to get our desired solution. So I hope you guys have understand the brute force approach of finding the maximum subarray problem. So if you see the solution of this problem using the brute force approach, the solution is quite simple. But if you see the complexity of this problem, you can see that the complexity of this corresponding problem is order of n square, which is not at all the optimal solution of finding the maximum subarray problem. And that is why we will be solving this problem in the most optimized way using the Kadane algorithm, which is very much popular and very important question for any technical interview. So let's see how we can find out the maximum subarray problem using the most optimized way using the Kadane algorithm. So far we have seen that how we can find out the subarray with maximum sum using our brute force approach. So the approach was quite simple. Using do for loop, we were finding all the possible subarray that can be produced from a given array, and we were calculating the corresponding summation value of each and every subarray. And based on the maximum value of the corresponding subarray, we were solving the maximum subarray problem. But for finding all the subarray from a given array, we were using two inner for loop, and that is why the complexity of the program was order of n square. But over here using the Kadane algorithm, we will be solving this problem in linear time complexity, that is in order of n. So the solution of this Kadane algorithm is very simple and easy to understand. It is just a 3 lines of code. But you have to understand the logic behind the solution of this problem. So since the time complexity of the Kadane algorithm is order of n, so it's quite clear that we will be using one for loop to iterate over the entire array. And just like the greedy algorithm, on each and every position of our iteration, we are finding the maximum subarray value that can be possible on this index. So to understand this algorithm properly, let's do a dry run over this array. So we will be starting our iteration from the first index of our array, that is from 1. And until this point, you can assume that the maximum subarray value is -2, since this is the only element that we have came across until this point. So the maximum subarray value until this point is -2. And the corresponding subarray that is considered until now is -2. Now while we are iterating forward, that is when we are starting our iteration from I equal to 1, we will first check the value of that corresponding index. So the corresponding index value is 1. Now we have to consider two things over here. Number one, we have to check that if we consider this 1 in our previous subarray, that is -2, whether it increases the value of the sum or not. So over here you can see that the previous value of the sum was -2. But over here, if we add the new element with our previous subarray, then our newly subarray becomes -2 and 1. And the corresponding sum of the array becomes minus 1. So over here you can see that if I consider a subarray of minus 2 and 1, the corresponding sum becomes minus 1 and the previous maximum subarray value was minus 2. So obviously there is an improvement on this given summation value. So this is our first check, that whether on adding a new element with our previous subarray, whether it is improving the summation value or not. And the second check that we have to do is whether the summation value that we are getting after adding this number is greater than the element itself or not. Means we have to find out the maximum of these two. So over here you can see that the summation value of this subarray is minus 1, whereas the value of the element itself is 1. So obviously if we start a new subarray from this point, that is 1, then the value of the subarray is maximum at this point. So which means that on each and every iteration we have to take one element and we have to check that whether on adding this element with the previous subarray, whether this is increasing the sum value or not. And if it is increasing the summation value, then we have to further check that whether this summation value is greater than the value of the element itself or not. Which means if the value of the element itself is greater than the previous summation value, which means we can start our subarray from this corresponding element itself. So I hope you guys have roughly got the concept of this algorithm. It will be much clearer when we will be solving it using our visual display board. So let's solve this problem with the visual display board with proper examples so that it will be easy for you to understand the algorithm thoroughly. So let's move to our visual display board. Let's consider that we have an array of numbers consisting of both positive and negative number, and we have to find out the subarray having the maximum summation value. And to solve the problem in the most optimized time, over here we will be using the Kadane algorithm. So let's understand the working principle of the algorithm. So as we have already discussed, to find out the solution using the Kadane algorithm, we will be using two variables. One as the local maximum that will compute the local maximum of a given subarray, and another as the global maximum which will return the value of the maximum subarray at the end of the iteration. So at the very starting of the program, we will start our iteration with the first index of our array. So at the very beginning of the program, the local maximum and the global maximum of this array is 2, since we have not encountered any other element before this. So we will initialize both the local maximum and the global maximum with the first element of the array. Now we will start our iteration with the second element of the array. Now we are at the second element of our iteration, that is the element is minus 3. Now over here, to find out the maximum summation value, we have two choices. Number one, we can add this new number with the previous subarray, that is with the 2, to form a new subarray like 2 minus 3. Otherwise we can only create another subarray with only element minus 3, but that depends on the summation value. So let's see how we will do it. So over here, if you see that if we take the new value minus 3 into our previous subarray, the new subarray that get formed over here is 2 and minus 3, and the summation of these two is minus 1. But whereas if we take only minus 3 as our new subarray, then we can see that among minus 1 and minus 3, minus 1 is the greater number. Means to find out the summation value of a subarray, it will be better to take both 2 and minus 3 as our subarray rather than only taking minus 3. So over here you can easily understand that between choice 1 and choice 2, we will be going with choice 1, because the summation value with the choice 1 is minus 1, whereas the summation value with the choice 2 is minus 3. So obviously, since we are finding the maximum subarray problem, we will always go with the solution that produces the maximum summation value. And that is why we are going with the first choice, that is choice number 1. And after that we are updating the global max over here. So the previous global max was 2, and now the local max over here, that is the choice 1, is minus 1. So there is no update on the global max value, and the global max value will remain as 2. Now we will keep on moving forward with the second item of the iteration. So over here on our previous iteration, the local max was minus 1, which comprises of these two numbers, that is 2 and minus 3. Now on the second iteration we got a new element, that is minus 4, where again we have two options, whether we have to include this value minus 4 into our previous subarray or whether we will create another new subarray from this corresponding number. So over here, if we add minus 4 into our previous subarray, that is with 2 and minus 3, the total summation value of all these three will be minus 5. Whereas if we take only this value, that is minus 4, as a new subarray, then obviously the summation value will be less. So over here, between choice number 1 and choice number 2, we will go with choice number 2, because the summation of the choice number 2, that is the element itself, have a higher value than all the summation value of its previous element. So over here the local maximum becomes minus 4 and the global maximum becomes 2, since there is still no update on the global maximum value. Now we will move to the next index, that is index number 3. So similarly over here also the last global maximum was minus 4, and over here we have the new element as 1. And again over here also we will have two choices, whether we should add this new element with the previous one or whether we should take this as our individual subarray. So in this way we will keep on computing and find out the local and the global maximum till the end of the array. And at the end of the complete iteration you can see that the global maximum, that is the maximum subarray value, is 7, which comprises of two elements of this subarray, that is 1 and 6. So over here you have seen that how easily using a single loop we have solved the maximum subarray problem using the Kadane's algorithm. And since we have used a single iteration over here, so the complexity of the problem will be order of n. So this algorithm might seem quite difficult to understand at the very first, but it is just the 3 lines of code to implement this solution. So let's move to the solution of this problem using the Java code. So I hope you guys have understand the solution of how to find the maximum subarray problem using the Kadane's algorithm. So let's write the Java code to implement the solution. But before that, if you have liked this video, don't forget to like and share this video. And if you are new to this channel, please do subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So let's write the Java code to implement the solution. So as we have discussed, we will be setting two variables over here. One a local maximum and one as a global maximum. Now we will write a for loop to iterate over each and every element over the array. So as we have discussed, the first step of finding this maximum solution is we will add the corresponding value of this index with our local sum. So on the next step, we will check that after adding the new element into our local sum, whether there is any improvement on the local sum or not. So if there is any improvement on the value of the sum, then we will add that corresponding newly added element in our subarray. Otherwise, we will create a new subarray from that element itself. And if there is any change on the local value of the sum, after adding this corresponding newly added value in our subarray, then we will be also updating our global sum as well. And at the end, we will close our for loop and return the global max as our output. So if you see over here, by using the Kadane's algorithm, we have solved this problem in linear time complexity. Thus the total time complexity of finding the maximum subarray problem is order of n. So hopefully you guys have liked the solution of this problem. I will be sharing the entire code of both the brute force approach as well as using the Kadane's algorithm in the description below. Please do check out the code and try to understand the code in detail, because this is an important question for any technical interview. So before moving to the next problem statement of our technical algorithm series, I would highly recommend you that if you like this video, please do like and share this video. And if you're new to this channel, please don't forget to subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So see you on the next video. Thank you.